All right, so in this video, we're going to be looking more at exponent properties, but extending our understanding to negative and zero exponents. So the zero exponent property helps us deal with exponents that are zero. To explain why the zero exponent property works, I'm going to use a quick example of 2 to the fifth divided by 2 to the fifth. So according to our quotient property, we should subtract the exponents of the like bases to get 2 to the 0 power. But also, just based on what we know about dividing a number by itself, 2 to the fifth divided by 2 to the fifth also has to be equal to 1. So the zero exponent property says any base raised to the 0 power equals 1. So regardless of what the base is, if you raise it to the 0 power, it's going to be equal to 1. Now, what we have to be careful of is we can only apply this property to a base that has a 0 exponent. So for instance, here, the only thing with the base of 0 is x. So the only thing equal to 1 is this term, or this portion. The 3 and the y to the 8th remain, giving me 3y to the 8th as my final answer. Whereas here, this 0 is being applied to the 4 and applied to the x to the second power, giving me 4 to the 0 and times x to the 0, which is going to be equal to 1 times 1, which is simply 1. So when it's outside of parentheses, the entire thing is equal to 1. Now let's take a look at negative exponents. So again, if we were to apply the quotient property, 3 minus 5 is negative 2. But if we were to expand out 2 to the third, that would be 2 times 2 times 2. 2 to the fifth is 2 times itself 5 times. We know that 2 divided by 2 is 1, and 2 divided by 2 is 1, and 2 divided by 2 is 1. So I'm really left with 2 2's being multiplied in the denominator to give me 2 squared, and 1 is left in the numerator because 1 times 1 times 1 equals 1. So what we know is 2 to the negative second is 1 over 2 squared. So the negative exponent property says a number raised to a negative exponent is the reciprocal of its positive exponent. Just a quick reminder of what reciprocal means. That might be a word that's sounding familiar, but you may have forgotten. Reciprocal is any time we take a number and flip it over. So for instance, 2/3 and 3/2 are reciprocals. The number 4 and 1/4 are reciprocals because 4 over 1, when flipped over, becomes 1/4. So when we have 2 to the negative 2, it has to be the reciprocal of 1 over 2 squared. And so that's how we simplify negative exponents, by writing them as the reciprocal. So the reciprocal of x to the negative 7 is going to be 1 over x to the positive 7th. We always want to get positive exponents. So x to the negative 7 gets flipped over to become positive. Same thing here. The reciprocal of 1 over y to the negative third is y to the positive third. If I flip this fraction over to make the reciprocal, I get y to the third over 1, but we don't typically write the over 1 in the denominator. So we just leave it as y to the third power. So a couple examples. For this first one, the only thing that needs to become the reciprocal is the x. The negative 3 power is not attached to the 6th, so the only thing that needs to move down to become the reciprocal is the x to the third power. So 6 stays up top, X to the third moves to the bottom, to the denominator, to become the reciprocal. Whenever we raise a fraction to a negative power, I personally like to just take the reciprocal and make the power positive. So, for instance, I would just take 4/5 and make it the reciprocal 5/4 and change the power to 3. The negative exponent means reciprocal. So if I take the reciprocal of the fraction that's in the parentheses, my power can then become positive. From there, we're going to cube 5 and cube 4 separately, giving us 125 over 64. 5 cubed is 125, 4 cubed is 64. All right, a couple more examples. So x to the 0, that is simply 1. So that's kind of gone from this problem. And then y to the negative 4, I need to move it to the denominator to make it the reciprocal. And so it's going to be 1 over y to the 4th power. So for this next one, there's a couple different ways to do this. I personally don't like to have negative exponents when I'm doing my properties. So I'm first going to take this denominator, x to the negative third, and move it up to make it the reciprocal. So I get 2x to the fifth, x to the third over 4. Now 2 over 4, that fraction is 1/2. So I'm going to simplify that to be 1/2. X to the fifth and x to the third is going to make x to the eighth. So I'm going to have x to the eighth in the numerator, and it's 1/2, but we don't have to write the 1 because the x to the eighth is already there. So my final answer is x to the eighth over 2. So for this next one, I need to do PEMDAS. I need to do the exponent first and then multiply by 6. So again, when a negative exponent is there, I'm going to take the reciprocal first and make it 6 times 3/2 cubed. I need to cube the 3 and the 2 separately. So I get 6 times 27 over 8. And now I can just multiply 6 by 27/8. I personally like to simplify on the diagonals if I can. 6 and 8 are both divisible by 2. So I can make this 3 and I can make this 4. I'm just dividing out a common multiple of 2. Now I'm going to do 3 times 27, multiply straight across the top, which is 81. 1 times 4 is 4, so 81/4 is my final answer. So again, with this problem, there's lots of different ways I could go about it, but I think the first thing that I'm going to do is I'm going to move the things that are negative. So this whole parenthesis is negative, so I'm going to move it to the denominator. And this y to the negative 6 is negative, so I'm going to move it up to make it positive. So now I have y to the 4th, y to the 6th over negative x squared times 3x cubed. So y to the 4th and y to the 6th make y to the 10th. I need to cube the 3 and the x separately to get x squared times 27, that's 3 cubed, x to the 3rd. And that's going to give me these two combined to make x to the 5th. So y to the 10th over negative 27 x to the 5th is my final answer for that one. And then the last thing that's very important is that 0 cannot be raised to a negative power. The reason is, and I like to use this little example to help me know when it's okay to have 0 and when it's not. It's not okay to divide by 0. Having 0 in the denominator is impossible. This is an undefined possibility. You can't divide a number by 0 because it doesn't make sense to say 10 divided by 0. Where do those 10 things go if they go into 0 groups? When I do 0 over a number, so okay, 0 divided by a number, I just get 0. If I had 0 divided by 10, 0 things divided amongst 10 groups means each group just gets 0. So if I had 0 to the negative 4th power, the reciprocal of that is 1 over 0. which is the no or the undefined setup. So anything raised to anytime 0 is raised to a negative power, your answer is undefined. This is super important. So let's make sure that we remember